We now determine the power of this complex number. That is, we have cosine of 5 times of pi by 4 plus I sine 5 pi by 4 raised to the power of 10. And we are going to find this using the Demoivre's theorem, which states that if z equals r times of the complex number, that is cosine theta plus I sine theta, then z power n, and this equals r power n times of cosine n theta plus I sine n theta. So we're going to use this Demoivre's theorem to determine the power of this complex number. So first, I'm going to consider the complex number z equals cosine of 5 pi by 4 plus I sine 5 pi by 4. So I consider the complex number without the power. Now I raise both sides to power of 10. So therefore this becomes z power 10, and this equals cosine of 5 pi by 4 plus I sine 5 pi by 4. This is raised to the power of 10. So when we use the Demoivre's theorem, we see that r equals 1 because we don't have any factor here or any multiple. So we can consider r equal to 1. So when we apply this De theorem, we see that it is 1 raised to the power of 10, which equals 1. And then we have to apply the De theorem, that is this 10 will get multiplied inside the argument. So therefore this becomes 10 times of 5 pi by 4, and we close this bracket, plus I sine 10 times of 5 pi by 4. So these two are getting multiplied. Now we have to evaluate this complex number. Let's simplify this expression, that is 10 times of 5 pi by 4, and this equals this is 5 times of 2, and this is 2 times of 2. So basically we get 5 times of 5 is 25, and pi by 2. So I'm going to write down this as 25 times of pi by 2. So we are going to write cosine of 25 times of pi by 2. We specifically write in this format so that we can determine the value quite easily. And then plus I sine 25 times of pi by 2. So now we have to determine this cosine value as well as this sine value. And if you could look here, we have cosine of 25 times of pi by 2. Uh, the cosine function, if it is an odd multiple of pi by 2, its value is 0. Odd multiple of pi by 2, then cosine of odd multiple of pi by 2 is 0. So here we see that this number 25 is odd. So therefore 25 times of pi by 2 and its cosine value is 0. So I put 0 here. Plus we then have I times of sine of 25 pi by 2. Let's see how to determine this value. For this I'm going to put this quadrant for reference. So this is our 0 degree, or we can say that this is 0 radians, and this is pi by 2, or we can say it is 1 pi by 2. This is pi, or it is 2 pi by 2, and this is 3 pi by 2, and this is 2 pi, or 4 times of pi by 2. So when we find the sine value of pi by 2, sine pi by 2 is 1 here, as well as after one complete rotation, this will be this will be 5 times of pi by 2, because here it is 4 pi by 2, and after another one more pi by 2, this will be 5 pi by 2. So likewise, if we go around this quadrant, this will be the next value at this point here will be this will be 8 times of pi by 2. So likewise, we have to go till 25 times of pi by 2. So basically, we need to know at what point this 25 pi by 2 comes in, so that we can determine its sine value quite easily. So I can consider this 25 times of pi by 2 as 24 times of pi by 2 plus one more pi by 2. If you look, observe here, This every time it it is getting bigger by 4 times of pi by 2. So this is 4 times of pi by 2, and this 8 times of pi by 2. So the next value is going to be 12 times of pi by 2. So likewise, at one point, this will be 24 times of pi by 2. Everything is multiple of 4 times of pi by 2. So at some point, this will be 24 times of pi by 2, which means we have reached the 24 times of pi by 2. And balance, we just have one more pi by 2. So that is, we have to go reach here. So basically, this 25, this is the place, or this is the point where 25 pi by 2 comes in. And at this point, all the sign value will be 1. So finally, we have figured out that the sign of 25 pi by 2 is, the value of this is 1. So I'm going to put I times of 1. So therefore, this becomes 0 plus I, or just I. So this is the complex number, and we can write down this complex number in standard form. That is, in standard form, since it is just I, we can rewrite this I as 0 plus I, and this is the power of the complex number.